Okay, let me connect the positive supply to the breadboard here. So this entire line will behave as positive today. Let me connect my negative supply here. So this will behave as minus 12. Now let's see whether I'm getting the potential or the voltages from the respective power supply or not. Now let me switch on the power supply, and I've connected the lead to the ground, and let me check whether it's giving me plus 12 or not. Yes, we can see it's giving 11.87, and if you see the negative one, yes, the supply is around 15.15. Okay, now we'll make the potential divider. First of all, take a 10 kilo ohms resistor connected in this fashion. Then we will have 1 kilo ohms resistor, 1 kilo ohms. So connect the 1 kilo ohms resistor. Here is the 1 kilo ohms resistor. This is the 10 kilo ohms resistor. Now take two 1 kilo ohms resistor, connect those in parallel fashion. And then connect the rest of the 500 ohms resistors. This is one, this is two, this is 3, and this is 4, and the last one is the 5th one. We can directly connect that to the ground pin, and we can extend the ground pin from here to here. We all know the breadboards have a termination here, so if the ground was connected to this particular line, we have extended that and it has been connected till here. Now let's have a very close look at the circuit. this is what 10 kilo ohms. After that we have 1 kilo ohms. After that there are two 1 kilo ohms connected in parallel. Yes, here you go. And there are 1, 2, 3, 4, and the fifth one. The fifth one has been connected to the ground like this. Okay. Now let us first connect the power supply. We all know the top of the 10 kilo ohms resistor has to be connected to plus 12 so that we will get a divided potentials. Let's connect that. And let's see whether that's working or not. I'm switching on the power supply. Let's check whether you've got around 12 or not. Yes, it's around 12 ohms. Now, the first one, say it's 0.2, sorry, it's 2 volts. That is just after the 10 kilo ohms resistor. After that you will get around 1 volts. After that you will get around 0.5 volts. After that you will get around 0.4. After that you will get around 0.3. After that you will get around 0.2, and the last one is around 0.1. There you go. So we have constructed a small potential divider which will provide us different voltages so that we can measure the input-output characteristics of the operational amplifier in the inverting mode. Now we'll have to finish the rest of the circuit. Now what does the rest of the circuit say? It says we have to connect the 7th pin to the VCC. So this is the 7th pin and it has been connected to VCC. Okay, as you can see in the circuit. Now connect the 4th pin. This is the 4th pin and connect it to the -12. I have extended the -12 from here till here. So I have connected the -12 from here to the 4th pin of the operational amplifier. Now let me take two resistors. I am considering two resistors of similar value. What I am considering is a 4.7 kilo ohms resistor. Now, the first 4.7 kilo ohms resistor will behave as a feedback resistor RF and it's connected between 6 and 2. So connected between 6 and 2. There you go. and then from 2 I will connect another resistor and leave the other end open. So from 2 I am taking as you can see I have connected the resistor on the second pin and left the other pin open. Now we have to connect third pin to the ground. Third pin is to the ground. Now one thing we have to remember here is it is an inverting amplifier, and hence in an inverting amplifier there will be a virtual ground at pin number 2. So if you don't get a virtual ground at pin number 2, there might be indication of loose connection or a faulty operational amplifier. So before we proceed further, it is very important that we measure the virtual ground. Now how do we do it? Okay, so let me first ground the input terminal and check with my meter whether the voltages are appropriate or not. So let me connect first to the negative one. Okay, the fourth pin is receiving negative voltage. Let me connect it to the seventh pin. Yes, it is giving me 12. Now let me connect the meter to the second pin. See, I have connected to the second pin and it's showing 0. That means we are getting a virtual ground. See again, here it is 0. So what we can see from here is there are no loose connections and also the operational amplifier is quite okay. Now we have connected the input of the resistor to the ground to measure the offset voltage. Now let me measure the offset voltage by connecting the pin to the 6th and changing the dial to 200 milli. What I can see there is some offset of around 1-2 amps. We have to remove this using a potentiometer. We have a potentiometer. Well, there you go. There are 3 terminals. Middle one is the slider one. That means if you rotate this, this will move. And these 2 are fixed. These 2 are fixed. The red one and the green one are fixed. So I will connect another terminal to 1, the other one to 5, and the slider to -12. We will now adjust the slider so that we get a 0. There you go. We have nullified the offset voltage. Now we can go on with our pattern. Now, since we have already constructed the potential divider, it will be easy for us to check the output voltage corresponding to different input voltages. So what we will do is we will connect a wire to the input of the resistor, and first connect it to say 2 volts. Now check the input voltage. It is 2.36. Let me check the output voltage. It is 2.38 minus 2.38. It's almost the same. Okay. Now change the input to a different value. Check the input value. It's 1.49. Check the output. It's 1.50 minus 1.50. Absolutely right. Now go to the next one. Check the input voltage. Use the same meter. We are getting 0.68. Go to the output, and we are getting. Let's check the input again. 0.75. 0.75. It's absolutely alright. Now move to the next one. It's in 4.43. The output is yes 0.44 or minus 0.44. It's absolutely right. Now check the other one. 0.33, and it is giving us minus 0.33. See, so since the gain is 1, whatever we are giving at the input, we are giving the negative output of it. So if we want to apply negative voltage at the input, just remove the minus 12 volts and connect it. Just remove the 12 volt from the top of the 10 kilo ohms resistor. Connect it to the negative. That is, from the 10 kilo ohms resistor, connect it to the negative supply, minus 12. Now you see we have an input voltage which is minus 33, and you will get output which is plus 1. See again, we have the input minus 0.41, we get an output plus 0.41. So you can see is whatever the voltage we are applying at the input is getting reversed at the output. The magnitude remains the same since we are using the same voltage. We are using the same gain, hence we are getting the same voltage at the output but with a reverse polarity. Now we can actually change the gain, and if we increase R1 with another 4.7K in series just like this, what will happen is you have a RF which is half of R1. That is, R1 is now 4.7 plus 4.7, that is RF is 4.7. So whatever reading we are going to get will be just half at the output. So let's see. We have applied an input which is minus 0.44. You will expect an output plus 0.22. See, we have an input voltage of minus 0.41. We are getting an output voltage of 2. So it's getting half. So the gain is half. Again, if I change the input voltage, see the input voltage is 0.33. I will expect it's half. That's 1.17. So what we can see is the voltages are getting half. This is because here RF is half of R. Thank you very much for watching the video. Hope you will like it. You can just practice it out at home. Thank you, and tune in for more videos. The next video would be the non-inverting amplifier, the differential amplifier, then we will make a square wave generator using operational amplifiers. Thank you very much. Bye bye.